Welcome to Unit 4, Lesson 3. The topic is monopolistic competition. It's the fourth and last of our market structures that we're going to analyze. And so far we've looked at perfect competition, monopoly, and oligopoly. And as we've already talked about in class, monopolistic competition falls along the spectrum in this way. If perfect competition is the most firms competing with undifferentiated products, and monopoly is the opposite, one firm as the only seller of the product. Oligopoly is just a few sellers, and monopolistic competition, the one that's not as obvious by just the name of it, is in between there. So on this side is the most firms, and this side, of course, is the least. There's a number of other things we could say along this spectrum, too. On the monopoly side here, the most profits, the most market power. On the perfect competition side are the least. The most barriers to entry in monopoly, the least barriers to entry in perfect competition, and all the way across. So monopolistic competition is going to be characterized by quite a few firms, many specific characteristics. They're going to be similar products, but differentiated is the word that's always used in monopolistic competition. So it's a number of firms kind of competing with each other in a similar market. Consumers are deciding between these firms' products, but it's not exactly the same product as it is in perfect competition. So a classic fast food restaurants along 86th Street. There's dozens out there for you to choose from for your lunch period. You've got, they're all kind of in the same market, but there's only one of them that sells the Whopper, and that's Burger King. So Burger King has a differentiated product that it wants you to prefer and to maybe even be willing to pay more for. And all the firms, all the restaurants along there would have the same deal. They're not trying to compete mainly by undercutting each other on price. They're trying to have a differentiated product usually that gets you in there. Of course, they can't be much higher priced than their competitors, but they're mainly competing by differentiating their products and advertising. Also, in monopolistically competitive markets, there are low barriers to entry. It's got to be relatively easy for firms to get in and out, and that's why there are so many of them. If it was hard, there wouldn't be that many of them. So we're going to look at a model of how monopolistic competition, how these markets behave, both short run and long run. Nice thing about this is that there's a lot of concepts that carry forward. Nothing brand new about monopolistic competition. We're going to take some of the things that came before and apply them to these markets. So first, the graph is that way. So on this slide here, we've got monopolistic competition in the short run. We've got two different scenarios we could have in the short run, either a profitable firm or an unprofitable firm. So let's say that our profitable firm is McDonald's and our unprofitable firm is Burger King. These are two firms. We have a separate graph for each. We're not putting the firms together on the same graph because they're selling kind of different products. That's one of the key points about these graphs. So over here on the left, this would be, let's say these are quantity of Big Macs, and on the right, this is quantity of Whoppers. On the left here, what we're seeing is that this graph looks exactly like a monopoly graph that's making a profit. Why is that? That's because since McDonald's is the only firm that sells Big Macs, if this is basically the demand for Big Macs, then McDonald's has a downward sloping demand curve. It has the entire demand for Big Macs. That also means that it has the same kind of marginal revenue relationship as a monopolist, meaning that if it wants to sell more Big Macs, assuming that the demand is the same, it can't shift demand out, let's assume that for the moment, then it's got to drop the price. So it's like a monopoly graph, but it still has a downward sloping demand curve. And it also has a downward sloping marginal revenue curve, which is below the demand curve at all points. So all that looks the same as it does for a monopoly. As long as its point on the demand curve where it sells, profit maximizing, remember marginal cost equals marginal revenue point, gives us the profit maximizing quantity. Bring that up to the demand curve to get the price. As long as this point here is above the average total cost curve, which is down here, then you've got a profit. That's what we're showing there. This is all review. On the right-hand side, we didn't look at this much with Monopoly, but say that you've got, for the Whopper, here's where the profit maximizing quantity and price are. But that price happens to be below the average total cost of production. So if cost is greater than revenue, that's why there we have a loss. So this is probably not actually the case, but let's say that Burger King is losing money and McDonald's is gaining money, as this shows, which, kind of like in perfect competition, it could be the case that in the short run, it could be worthwhile for a firm to lose money if it's losing less than its fixed cost, until it either is able to compete its way back or to sell off its fixed inputs. Kind of same deal as we talked about in perfect competition in the long run. So, the point being made by this slide is that in monopolistic competition, the graph represents basically a single firm's, the demand for that single firm's good, and that in the short run, it could be either profitable or it could be losing money. But just like in perfect competition, firms won't continue to lose money, and because there is free entry and exit, you'll have a similar attractive quality to firms making profits that will induce other firms to come in and try to get a piece of those profits. It happens a little bit differently than it does in perfect competition. Remember, in perfect competition, the transition happened through a shift in the market supply. Well, here we're not dealing with an entire supply and demand graph of the market like we are in perfect competition. We're dealing with individual firms and the demand for their goods. Demand for Big Macs, demand for Whoppers. So let's just take one of these at a time. Say for McDonald's. That McDonald's was one of the first fast food restaurants along 86th Street. Back in the day when I was growing up, and there was not a whole lot around Brebeuf, there was McDonald's and maybe one or two other fast food places on 86th Street. There were long stretches of nothing. So let's say that this graph here represents McDonald's in the 1980s, making a hefty profit. Over the years, as more and more firms saw the profitability of that store, let's say, they decided to set up stores of their own along 86th Street. What we would say that would probably have done to the McDonald's demand is that it would have shifted it to the left. Let's just deal with, on this graph, the two demand curves here, D1 and D2. Let's say D1 is McDonald's on 86th Street in 1985, and D2 is demand for McDonald's in 1995. Over those 10 years, as more firms entered the market at 86th Street, it would have peeled off some of those customers, some customers who were just going there out of convenience because it was the closest thing, who worked in the office buildings around there, whatever, would have then chosen to go to these other new restaurants instead. So an increase in competitors basically took some of McDonald's demand, shifting the demand for Big Macs to the left as more competition comes in. Think of this now as both demand and marginal revenue. These two, since they're mathematically related, those two kind of shift together. So there's the original 1985 demand and marginal revenue. If the demand shifts over here, it kind of takes the marginal revenue with it. So the whole thing shifts to the left there. All that would happen as a result of entry of additional firms into the market to compete with this McDonald's. So that should happen as long as there are profits being made in this market that's open for competition, where there's free entry available. And it should happen until the demand and marginal revenue shifts to the left enough. Let's go back on this graph and try to see. That's what happens if I shift now the demand, say, over here, like that. So what's happening there is that here's our new profit maximizing quantity and price. Don't try to draw this on your slide, by the way. It's going to look like a mess. So let's just see what's happening here. We shift the demand and marginal revenue to the left. Here's the new profit maximizing quantity. Here's the new profit maximizing price. Where is that compared to ATC? It's right about on it. I did that on purpose. Because at that point, there is no profit. When the ATC is tangent to the demand curve at the profit maximizing point, the firm is breaking even. That's what this next slide down here shows. Much cleaner here. Profit maximizing quantity, price. If it's tangent to the average total cost right there at point Z on this slide, this is a firm breaking even. At that point, if McDonald's were breaking even, again, let's call this hypothetical because they're probably not. If the firm is breaking even, then no more firms are induced to come into this market by because of profits, because the profits are not there anymore. They've been competed out. This should sound familiar to what we did with perfect competition. It's entry of new firms into the market, kind of competes the profits away. It does it in a slightly different way in this model than it did in perfect competition, where it affected the market supply, the demand for the firm's product, because it kind of peels customers away. But ultimately, the result is the same. Firms are now, in the long run, we would call this a long-run equilibrium for monopolistic competition, that the firms should be now breaking even and being okay with that over the long run if that stays in a stable state, because again, they're making accounting profits, not economic profits, but enough for them to stay in this industry. Let's go back to the reverse. If firms in general are losing money, let's take the Whoppers, for instance, the Burger King. Let's say that Burger King decided, okay, we're losing a little bit of money now, but we're going to stay in the industry over the long run. If other firms were losing money too, since Burger King is still stuck around, let's assume that they stuck it out, and but there are some other ones that didn't make it. I can't remember what was around there. Let's say there was a Burger Chef or something like that. You've probably never heard of it. There was something that was around in the 80s that's not around anymore in the 90s. As firms exited because of losses, then more people now are driven to buy Whoppers at Burger King. The demand for Whoppers from 1985 to 1995 shifts to the right, because now more firms coming in, firms leaving the market, meaning that more customers are coming in to Burger King, shifts the demand and marginal revenue to the right. And if we go back up to this graph, we can shift these to the right just a little bit, basically, like this and this. That's going to put us again back at that point of tangency. I'm not going to try to make it look nice on there. Let's just bring it back here. It would eventually go back to the demand shifts to the right until that loss is taken away and it's back to the point of tangency, breaking even in the long run. So the ultimate effect of either the firms that are making money and other firms entering, or the firms losing money and other firms exiting, they all end up back at this long-run equilibrium where firms are breaking even with accounting profits but no economic profits. And this all sounds like a similar outcome, right, as perfect competition. Let's say in some ways this is like perfect competition. In our next lesson, we'll see how it's not exactly like perfect competition and why that's significant. But for now, let's notice that this whole fact that there's a short-run to long-run transition, and that the outcome of the long-run transition is that firms breaking even, that is like the perfect competition model. And so, put together, what we've seen here hopefully explains why. This is usually people's first question. Where does this phrase come from? Monopolistic competition. Well, for these industries, they're monopolistic in the sense that they've got a downward sloping demand and marginal revenue curve. They're the entire demand for their particular type of product. That's like a monopoly. That's monopolistic. McDonald's has a monopoly over Big Macs. But they're competitive in that there's easy entry and exit, and that easy entry and exit causes, over the long run, firms to break even, because more firms are attracted to profits and firms get out if there are losses. And there's an adjustment process that happens bringing it to this long run equilibrium point. Okay, that's it for this lesson. See you in class.